This is stop 26. It's on the southern side of the Columbia Falls Delta, and we're looking at a wave-cut cliff and beach system that's cut into the southern southern part of the delta, along the front face of the delta. The ice, the delta is over here, and if you cross over go up the slope here and onto the flat surface, you're on the delta, and the ice lay to the north of that. The meltwater coming off the delta simply built the delta sand and gravel deposit into the ocean. And so the top of the ridge here roughly represents the ocean level of the time, which is 250 feet above the present level of the sea. But as the ice went back, the land rebounded and came up, and sea level dropped relatively about 20 feet. And the ice now is gone, so the delta isn't building forward, and so the sea simply cuts a notch in the front of the delta at about 230 feet high, and that edge is right there. So if you went to a modern beach and asked the question, where would you put your beach blanket, you'd sort of put it right down where we're standing, and there'd be a cliff behind us like Cape Cod, and that's where the storm high tide would come and cut the cliff. But normally the ocean would be about where we are, and there'd be beaches here and people sitting on their beach blankets. So this cliff is the same cliff as traceable over to the Pineau Ridge Delta just to the west of us here, and is traceable for another 100 miles up towards St. John, New Brunswick in that direction, and in fact past the Pineau Ridge down into central Maine at the same level. And that's the way this area developed. One of the questions, of course, is, as we discussed for the Pineau Ridge Delta, what time of year did this cliff get built? Normally in New England, it's the winter time when we have northeasters that pound into the seacoast and do a lot of erosion, particularly on soft sediment like this. But here it's different, because if we analyze the ocean bottom sediments out here, it's bottom sediment, that mud that came out of the base of the glacier due to the grinding of the ledge further north. It spits out, finally deposits that pulverized rock dust that's like sandpaper dust, only it's rock dust, out into the ocean and settles. But at that time, marine organisms lived in that material. And if you look at the shells particularly, or the walruses, or the whales that we found in this sediment, we find out that the environment at that time was that of central or northern Greenland today. So when this cliff was formed at about 15,300 years ago, the environment here was Arctic. And so if you go to Greenland today in the winter, what you find is that the sea surface is all frozen up there in the winter, and no ocean action goes along at all along the shore. The erosion takes place in the summer months when there is no ice. So I presume the same thing is true here. So probably this cliff was cut during the summer months by the prevailing wind or the prevailing storm directions. One might ask, what was the prevailing wind at that time? And the way you tell is to follow the cliff along in either direction and analyze the situation whereby the sediment being eroded is transported in that direction or transported in this direction by the current along the beach. Well, if the waves come in from this direction, they hit this cliff at an angle, and the sediment being eroded is transported in that direction. If the waves come in this way, the sediment is transported in that direction. An analysis of this area shows that the sediment was transported eastward in that direction, and sandbars and spits were built out just as they are along the modern New Jersey coast or southern New England coast, where you have the big sand beaches, or even the Maine beaches. And though the direction then that those are built in towards the east demands a wind direction coming from over here, which is southwest. So we can analyze this and say the prevailing summer wind at 15,300 years ago was probably from the southwest, as it is right now. It's coming from the southwest today, but for an entirely different set of atmospheric reasons that I don't understand. But the southern, so we can analyze things in a very rough way and come to some conclusions about the paleo environment at 15,300 years ago along this area.